Mr. Chairman, ladies and gentlemen, good afternoon. I'm honored and proud to have the opportunity to speak at this meeting. Today, I would like to present my report, Research on Mechanical Properties and the Micromechanism of the Graphene Statement-based composites. My presentation will cover the following aspects. Now, please look at the part 1. All along human beings are facing the problem of ice and snow disaster. How to realize the functionality of cement-based materials melting ice and snow is challenging. How to realize the healthy detection of the concrete structure is also an effective means to avoid safety accidents. And while development of the electromagnetic shielding the performance of the cement-based composites is important, which can protect the human from electromagnetic radiation. Therefore, study on cement-based functional composites is of the great significance. Graphene as the two-dimensional materials with excellent comprehensive properties has become a research hotspot. Tensile strength is 130 GPa. Elastic modulus is 1 GPa. Thickness is only 0.34 nanometer. As we can know that graphene has many advantages, and then how do these properties affect the cement-based materials, such as physical and chemical interaction with silent matrix, comprehensive strengths and flexuous triangulations, pore structure and hydration process. However, the dispersion and the stability of the graphene in cement matrix are poor. Dispersion of the graphene in aqueous system, preparation of the head concentration and the stable of the graphene dispersion and the key factors for the development of the graphene cement composites. Therefore, significance of the dispersant and different ultrasonic methods were used to prepare the graphene dispersions in this study. Finally, the best dispersant and the most suitable ultrasonic method was determined. Next, please look at part 2. Ultrasonic cleaning instrument has a low sound intensity, stable dispersion, and no solution splash, so it is suitable for the prep dispersion equipment. Ultrasonic sound renders the stronger radiant sound wave at the end of the crash, so the strong and uniform shock wave and macro jet are formed in the reaction in liquid. This picture shows that the preparation process of the graphene word suspension and the test symbols. Next, please look at the part 3. This picture shows that the functional graph and the thick dispersants. We can see that these dispersants have both hydrophilic graphs and hydrophobic graphs. This picture shows the absorbance of the graphene in different dispersions. We can see that the absorbance of the NS is the largest. According to the number below, NS has the best dispersing ability. In addition, this picture shows that the absorbance of the graphene in different concentrations. The result shows that the mass of the NS and graphene is 2:1:1. The Absorbance is the largest. The dispersing ability is the best. This picture shows that the state of the graphene dispersion with the different dispersions after stick setting for 6 hours. We can see that the uniformity of the number 3 dispersion is the best. The picture shows that the state of the NS graphene suspension with the different concentrations of the static setting for 6 hours. This picture shows that FTIR analysis result of the dispersants graph and the suspension. From this picture, we can see that there's no chemical reaction between the graph and the dispersant. Just there's the physical absorption. According to the experimental result, the summary is as follows. Next, please look at part 3, part 4. This picture shows that the fluidity of fresh metal. The result shows that the fluidity of the metal is decreasing with the addition of the graphene. This is mainly due to the large specific surface area of the graphene absorbs a lot of water. This picture shows that the mechanical properties of the metal with the different graphene contents at 3 to 7, 28 days. We can see that the compressive and flexure strands show the first increase and then decrease the tendency with the increase of the graphene content. In addition, the effect of the graphene content on the early ages of the transients is the most significant. Next is part 4. This picture shows that the hydration exosemic curves of the metal with the different graphene content. The result demonstrated that exosemic rate of the symbol was gradually increasing with the increase of the graphene content. The peak viewed was the largest when the content of the graph is the 4 white percent and 2 white percent is lower. However, there is no obvious difference in hydration rate when the cement hydration entered the stable stage. This is mainly due to the nuclearization effect of the graphene, which increased the contact area between the cement and water when graphene particles absorb on the surface of cement. This picture shows the size and the distribution in the hydration cement matrix. The porosity of the hardened mixture was significantly reduced with the introduction of the graphene. When the content of the graphene was the 2 weight percent and the porosity was decreased by 31% compared with the standard symbol. This picture shows that the small size pore increased first and then decreased, and the largest size pore was basically the same. This result illustrated that the graphene particles were filled in the large pores of the cement pore to form plugging effect, and the number of the small pores has increased within 30 regions of the graphene content. This picture shows that the distribution of the graph and the improvement mechanism in the cement matrix. The enhancement mechanism of the graphene in cement matrix is mainly due to the nanoscale and 2-dimensional morphological factors. This is easy to form network structure in cement matrix, and compacted its international structure reduce the porosity and refined pore size. This picture shows ESEM of the graphene Statementbased. To better understand the mechanism of the graphene and proving the strengths of the Statementbased materials, we have to measure the ESEM of the graphene and the Statementbased with the 1% graphene. A lot of the graphene laminar structures are distributed in the hydrogen protectors of the cement, which not only fill the pores, but also make the structure of the hydrogen products more denser. According to the experimental result, the summary is as follows. Next is the last part, conclusion. This is all my conclusion. That's all my topic. Thank you for your attention.